Hello students, today we will study a very important topic of differential equation, that is Green's function, which is very useful for M.Sc students as well as for NET aspirants. Our contents will be Green's functions, properties of Green functions, procedure of constructing the Green's function, solution of boundary value problem. Let us start the definition. Green's functions are named after the British mathematician George Green, who developed the concept in the 1830s. Green function is also called influence or auxiliary function. Green's function method enable the solution of a non-homogeneous ordinary linear differential equation of any order with certain boundary conditions. Definition of Green function. A function gxs is called green function of the given boundary value problem, that is d by dx px dy by dx plus qxy is equal to fx with the boundary conditions a1ya plus a2y dash a equals to 0 and b1yb plus b2y dash b is equal to 0. The given differential equation is known as Sturm-Liouville differential equation and the conditions are Sturm-Liouville conditions, and the whole problem is known as Sturm-Liouville boundary value problem. If any function satisfy the below mentioned properties, then it is called Green functions. Properties of Green functions. The Green function gxs is continuous with respect to x for a fixed s. Means Green function is always continuous for every value of x for a fixed s. Second property, the partial derivative of g with respect to x of first and second orders are continuous functions of x where x is not equal to s. Means when x is not equal to s, then partial derivatives of g with respect to x for first and second orders are always continuous. But third property, at x equals to s, the first order partial derivative of g has a discontinuity of the first kind with a jump 1 upon ps. What is ps here? The coefficient of d2y by dx square by replacing x by s is known as ps. Fourth property, for each fixed s, the function gxs is a solution of the corresponding homogeneous equation. Means, as we see the above equation, for fx is equal to 0, the given Sturm-Liouville equation becomes homogeneous equation. Now, procedure of constructing the Green's function and solution of the boundary value problem. First, find two linearly independent solutions ux and vx of the homogeneous part of the differential equation. Means first we put fx equals to 0 in above Sturm-Liouville equation, that is d by dx px dy by dx plus qxy is equal to 0, satisfying the conditions one for ux and the other for vx. a1ya plus a2y dash a is equal to 0 and b1yb plus b2y dash b is equal to 0. Step 2. Compute the Wronskian. What is Wronskian? Wronskian is a function which is in the form of determinant and which shows the given solutions are linearly independent or not. If Wronskian, that is wx, is not equal to 0, then the solutions are linearly independent. And the formula for wx means Wronskian is ux v dash x minus u dash x vx. What are u and v? U and v are here linearly independent solutions. After calculating the Wronskian, we come to C. What is C? C equals to px into wx. The solution will exist only when Wronskian is not equal to 0. Third step, construct the green function. Gxs equals to Vx us upon c if s is greater than equal to a and less than equal to x, and second part, ux vs upon c if s is greater than equal to x and less than equal to b. The given boundary condition is then given by yx equals to a to b gxs fs ds. Now we see example. Example 1. Find the Green's function for the following boundary value problem. Y double dash x equals to fx, where the boundary conditions are y0 equals to 0, y1 equals to 0. Hence, solve y double dash x equals to s square subject to the same boundary conditions. See the solution. First, we convert the given equation into homogeneous equation by putting fx equals to 0. The homogeneous equation becomes y double dash x equals to 0, and after integrating 2 times, we know that its general solution yx equals to ax plus b. Step 2. To find ux and vx. What are ux and vx? Ux and vx are linearly independent solutions. Now we put x equals to 0 in equation 1, and using the first boundary condition, that is y0 equals to 0, we get b equals to 0. So put the value of b equals to 0 in equation 1, we get yx equals to ax. If we choose, because a is arbitrary constant, therefore if we choose a equals to 1, then yx equals to ux equals to x. Again using second boundary condition, that is y1 equals to 0, in equation 1 we get a plus b equals to 0, means b equals to minus a. Now choosing b equals to 1, so a will become minus 1. Putting the values of a and b in equation 1, we get yx equals to vx equals to 1 minus x. So we have constructed 2 linearly independent solutions, ux and vx. Now to find Wronskian, to check the solutions are linearly independent or not. The formula of Wronskian wx is ux v dash x minus u dash x into vx. Putting the values of ux, v dash x, u dash x and vx from above, we get Wronskian equals to minus 1. Also, in this differential equation, the coefficient of d2y by dx square, that is px, equals to 1. So, c equals to px into wx equals to 1 into minus 1, that is minus 1. So, the green function is s into x minus 1 if x is greater than equal to 0 and less than equal to s, and x into s minus 1 if x is less than equal to s and less than equal to 1. The solution is given by y equals to integration 0 to 1 gxs into fs ds. We break into 2 parts, 0 to x and x to 1, and putting the value of gxs from above, and after this we substitute the value of fs is equal to s square, which is given in our question. We get yx equals to x minus 1 0 to x s cube ds plus x into integration x to 1 s minus 1 s square ds. On integration, applying the limits of integration, we have yx equals to 1 by 12 x4 minus x. Thank you.